Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for a speaker in the question answer window on your screen. After the presentation, I will begin the question and answer portion, and I will ask our speakers your questions from the question and answer window. Your questions in the question and answer window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Xiao from GenScript ProBio.
Explaining to you the way to achieving extreme biologics volumetric productivity and how GenScript ProBio approaches that. My name is Xiao Pan. I'm the Director of Process Research and Development in GenScript ProBio. A little bit introduction about GenScript ProBio. Our vision is to be your most reliable and sustainable biologics partner. And the three bios formulates our brand name ProBio, which are proactively will approach our customers proactively, treat you professionally, and deliver professional processes. Up to now, we have basically two sectors and two strong arms in both antibody drug development as well as gene and cell therapy. For both of the sectors, we are building one-stop shop from discovery to preclinical development to early stage clinical as well as late stage and commercialization. We are also building on our GMP virus manufacturing for commercial use for gene and cell therapy, and we're building antibody drug development or expanding our commercial manufacturing facilities in both fed batch and perfusion processes. Back to the business, I'll be talking to you about how GenScript ProBio approaches process intensification. First, I'll give a bit of scope and trend on process intensification. During the last decades, the titer of biologics increased significantly from point-something gram per liter level towards currently above 3 gram per liter level. This great titer increase brings significant cost reduction in terms of dollar per gram of substance. In the future, the current process is calling for further process intensification to bring the cost further down as a paradigm shift. The process intensification we're talking here includes quite a broad concept, which are digitalization, process automation, simplification, miniaturization, and the hot topic, continuous bioproduction. The aims are to increase productivity, capacity, titer, throughput, etc., and eventually to decrease the cost per gram of antibody. So how GenScript works on developing intensified perfusion or intensified fed batch processes. We are doing so ultimately we want to be able to build an intensified fully continuous process for all the way from upstream to downstream and fill and finish. In this road, we're developing blockwise, basically starting from upstream, we're building our high density banking capability and also high density seed train solutions, including N-1 or to N-X. And at our N stage, we are building perfusion and intensified fed batch processes. For downstream, where we currently have a continuous capability to do continuous capture step, and we're extending this to fully continuous downstream process. And above this, there's an overarching supporting tool that is process analytical technology in both up and downstream to provide online monitoring and feedback control, basically to have higher degree of control over the continuous process to guarantee more robust process runs and scale up. With an example of upstream intensification, in the end, we want to be able to offer different scenarios that is capable of handling different products as well as production needs. So different combination of seed train and upstream processes will give different features to the processes. For instance, the culture longevity, the maximum viable cell density, as well as the typical product titer will be different for each of the combinations or the scenarios. And of course, the process complexity and the degree of easiness in further process scale up is different. Some case studies of process intensification I'll be talking about in the next few slides. The first case is quite straightforward, a high-density inoculation fed batch process. By increasing the inoculation density, the integral viable cell density is correspondingly increased, and this resulted in proportion increase of final product titer. The concept itself is very straightforward, and it doesn't change the fact that we're still running a batch-wise process. So in this process, we start by getting a high density seed train, N-1. We perfuse the culture to reach 80 million cells per ml, and we use this seed train to inoculate different processes ranging with inoculation density ranging from 0.5 million cells per ml to all the way up to 41 million cells per ml. As you can see, the integral viable cell density increased proportionally with our inoculation cell density. Up to culture day 15, the viability for all the processes running here maintained well, and even with 41 million cells per ml, up to 15 culture days, the viability is still above 70%. At day 13, we've tested the titer of the cultures. As you can see, the titer increased linearly with the inoculation density as well as the peak viable cell density. So in the end, for this process, we've increased the titer compared to traditional fed batch, 3.5 gram per liter. This one was increased to nearly 7 gram per liter by increasing increase the inoculation density. To further test the the universality of this process, this concept, with expanding the testing on different products, like some monoclonal antibodies, 2 biosimilars, and 1 trispecific mAb. For processes with different titers, by increasing the seeding density, here we tested was 12 million cells per ml in inoculation density. The titer increased 130% to 250% in the range of this fold increase. It's good to mention that for this specific trispecific antibody with 0.5 liter per gram per liter of product titer, which was considered economically unfeasible, but just by increasing the inoculation density, it increased to 1.1 gram per liter, which was we changed this process to a viable process. And we've also tested the product quality attributes compared between these two inoculation densities. As you can see here, the chart, the glycosylation as well as the purity of the products remain constant compared between these two seeding densities. In the case 2, I'll explain to you in a development way how we develop an intensified perfusion process. For this process, we started by screening the media and cell-specific perfusion rate, the CSPR mean, for this process. In the media screening process, we've used 3 different media, and as you can see here, the contour map tells us that basically the richer the media it is, the higher the mean QP you will get from the process. And we've also known that the second media has had the biggest contribution to the positive contribution to the performance of the process. And we further enrich the media using a certain percentage of feed. And in the end, in the third group, we've achieved a process with a very impressive QP, which reached 100 picogram per cell per day. Then in the next step, we use this condition to run a semi-continuous perfusion process to test the cell-specific perfusion rate. And at 1.2 VVD volume per day perfusion rate, the cell viability and cell growth was maintained well. And in the next step, we've confirmed the previous screened parameters in 3-liter bioreactors. Here we run 3 consecutive and repetitive runs for this process using intensified perfusion process. As you can see here, these process runs are characterized with very high consistency along between different batches with very narrow error bars for cell growth as well as viability profiles. And during the culture, we've got the volumetric productivity up to 3 gram per liter per day. And with 26-day culture, we've got accumulative volumetric productivity up to 45 gram per liter. And so along the culture from day 11 on, we've also tested the product quality attributes, how it changes during the culture, because we're doing a continuous culture here. There will be perfusion culture constantly coming out of the bioreactor, and therefore we've tested different days along the culture, the charge variance of the product quality attributes, as well as the charge variance, as well as the protein purities are quite constant along the culture days. So for this, along with the previous mentioned perfusion process, we've also tested different scenarios for this intensified perfusion process. Compared to traditional fed batch process, which convert to a time and volumetric productivity of 0.25 gram per liter per day, which is a typical fed batch culture performance, viable cell density of 25 million cells, QP20 PCD. In the first perfusion process, we've kept the viable cell density around 30 to 40 million cells per ml. And with that, we achieved a time and volumetric productivity of 2.6 gram per liter per day. And in the second scenario, we pushed the viable cell density to the max, nearly 170 million cells per ml. With this one, we were able to achieve time and volumetric productivity of 6.2 gram per liter per day. But this is very, we consider this viable cell density is very challenging for our perfusion system, both for the ATF hardware as well as for the to control the perfusion. Therefore, we've targeted the culture, like the operating space with a viable cell density of between 50 to 100 million cells per ml. It's a reasonable viable cell density range. And with that, we can keep the time and volumetric productivity between 3 to 5 gram per liter per day, which is a very also a very impressive volumetric productivity. So in the end, the intensification of both fed batch and perfusion processes aim to bring economics effects. With the volumetric productivity increase and plus the media cost down, we have our ProBio's customized performance media system, which is very high performing media with very low cost. Specifically designed for fed batch as well as for perfusion systems. This brings our media cost down and further process intensification to use continuous capture, continuous affinity chromatography, and the continuous ion exchange chromatography. The resin cost in downstream will be significantly reduced as well. And in the end, these all sum up to contribute to a nearly 70% decrease of the antibody manufacturing cost. So finally, I'll explain. I'll give you a bit of perspective on the future technology enablers and what GenScript will continue to work on to equip our perfusion and the continuous process with more cutting-edge technologies. With an example of upstream process, currently there are many technology enablers to online control the processes. For instance, online metabolic analyzer, auto sampler, as well as inline cell imager. These technologies can give us high resolution of our processes. Compared to the traditional one sample or two samples per day, these online control technologies allows us to have more higher resolution and higher data frequency, which help us to better understand our process as well as to control our process in a real-time fashion. These should be supported by a comprehensive and strong data system, of course. That includes automatic data acquisition and data analyzing system, and a control protocol that supports the data acquisition as well as feedback control. In addition to that, future bioreactor design as well as miniaturization and high throughputness will also bring further timeline, shorten the timeline and reduce the manufacturing cost. With that, I want to thank you for your attention.
Thanks, Xiao. So the first question is, how would GenScript ProBio adapt their feeding strategy if a high-density inoculation process is used?
Well, as shown in the presentation, the cell grow very well in the high-density inoculation processes. However, behind the high-density inoculation culture, there was feeding strategy optimization, of course. We designed nutrient feeding based on per cell requirement and convert and normalize the value to guarantee to generate a feeding factor, which is dependent upon inoculation density, culture time, and cell-specific growth rate. But in reality, it is rather simple than it sounds now.
Okay. And how do the high-density culture solutions impact CMC timelines for the IND applications?
Well, if a high-density inoculation fed batch is used, it doesn't impact the whole CMC timeline a lot. We designed the high-density inoculation fed batch in such a way that the development timeline is still comparable to the traditional, like 0.5 to 1 million cells per ml inoculation density fed batch cultures. But for perfusion processes, some extra parameters will need to be tested on top of the traditional fed batch cultures due to the complexity of the process itself. That requires some additional rounds of experiments, but it will not give some significant extra timeline to the whole development timeline still.
Okay, and how does the GenScript ProBio cell line react to the high-density processes?
I would say, in general, our current CHO cell line reacts, matches the high-density processes very well. You can also see from the cases in the presentation that the cell line in the perfusion culture, the cell line can grow to very high cell density, about 170 million cells per ml. And also, our cell line have a great potential to achieve high QP, the specific productivity, up to 100 picogram per cell per day. That's already very high. And also, our cell line, it copes the perfusion environment very well in terms of shear insensitive, and it's proven to be scaled up to 2,000 liter, and that all showed a very flexible and potent cell line. In the meantime, we are still seeking for further cell line optimization to further enhance the productivity of the cell line.
Okay, and it looks like we have time for just one more question. If we don't get to your questions, please go ahead and type them in. If we don't get to your questions, we'll be passing them on to Xiao, and he can follow up with you directly. For the last question is, what kind of product suits the high-density inoculation or perfusion process according to GenScript ProBio's experience?
I think the direct application of the high-density or perfusion process would be for difficult to express products or for a product that needs clinical high dose. As shown in the presentation that, for example, a tri-specific mAb, which had 0.5 gram per liter titer produced using traditional fed batch culture, that by simply increase the inoculation density to about 12 million cells per ml, the titer of that tri-specific mAb production can be increased to over 1 gram per liter. So in this case, just by simply increase the inoculation density, it turns an economically unfeasible process to a viable process. And that's how we see where this process fits the best. And also for labile products, for example, some enzymes and factors that are sensitive to the culture environment, perfusion culture is known to be able to remove the waste metabolites, and therefore and also the retention of the products in the culture environment is very short. Therefore, it also suits the products that are vulnerable. Something more to that is for instance, for biosimilars, where the products needs high degree control over the product quality. In this case, the perfusion process, which culture enters the steady state, it can be used to control the product quality in a real-time fashion.
Thanks, Xiao. And thanks to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future BioProcess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.